Hi, this presentation is about emission defeat devices that was recently used in the automobiles with diesel engines. Modern vehicles are required to comply with a range of environmental regulations limiting the level of emissions for various greenhouse gases and toxins. To ensure compliance, regulators test vehicles in controlled settings and measure their emission at the tailpipe. However, the black box nature of this testing and the standardization of its form have created an opportunity for evasion. Using modern electronic engine controllers, manufacturers can programmatically infer when a car is undergoing an emission test and alter the behavior of the vehicle to comply with emission standards, while exceeding them during normal driving in favor of improved performance. Diesel engines versus gasoline engines. The distinguishing difference between a gasoline and diesel engine is the manner in which combustion is initiated. Gasoline engine, a mixture of air and fuel, is drawn into the combustion cylinder and ignited by spark. In a diesel engine, air is drawn into a combustion cylinder and at critical point in the compression cycle, fuel is injected into the cylinder, igniting in the compressed air. Thus, in a gasoline engine, fuel and air are mixed before being drawn into the cylinder and ignited, whereas in a diesel engine, fuel and air are mixed at the time of ignition, resulting in imperfect and inhomogeneous mixtures. This is responsible for many of the diesel engine distinctive characteristics, including the black smoke and heavy knocking sound known as a diesel knock. The black smoke, made up of particulate matter, also called soot, results from the incomplete combustion of the fuel and is subject to strict limits in light-duty diesel vehicles. The second major pollutants in diesel exhaust are nitrogen oxides. Current emission standards impose tight limits on the amount of particulate matter and nitrogen oxide emitted and require special steps to limit their levels. Electronic engine control. In a typical model car, there are 70 to 100 electronic control units that are responsible for tasks such as the human-machine interface as part of the infotainment system, a speed control unit, a telematic control unit, or brake control modules. Among these is the engine control unit, ECU, which is responsible for the operation of the engine. At its core, the ECU implements a closed control loop by periodically reading sensor values, evaluating a control functions, and controlling actuators based on the control signals. To control engine behavior, the ECU relies on a multitude of sensors reading, including crankshaft position, air pressure, and temperature at several points in the intake air mass, fuel, oil, and coolant temperature, vehicle speed, exhaust oxygen content, as well as driver inputs such as the accelerator pedal position, brake pedal position, cruise control settings, and selective gear. Based on these sensor inputs, the ECU implements different functions to control and influence the combustion process by interpreting the input data. In a diesel engine, one of the most important control values is the fuel injection timing that defines when and for how long the fuel injectors remain open in the engine cycle. Injection timing affects engine power, fuel consumption, and the composition of the exhaust gas. The ECU also determines how much of the exhaust gas should be recirculated and how much should be injected into the exhaust to catalyze nitrogen oxide. The ECU uses the computer control signals to directly control several actuators, most notably the fuel injector valve and air system valves, including the EGR valve. The ECU also communicates with other systems inside the car, for example, to display the current engine speed, RPM signal, or light up the diagnostic lamp. Furthermore, status information about the ECU is sent via an interface such as the onboard diagnostic system, and the ECU can also communicate with other control units via the CAN bus. So, what's the issue? The software inside several diesel cars was modified to determine whether the car is being tested or not. During testing, the car reduced emission below the legal limit, and during regular driving, the emissions was above the legal limit to improve the performance of the car. Scandals relating to higher than reported emission from diesel engines began in 2014, when the International Council on Clean Transportation reported discrepancies between European and US models of vehicles, beginning with the Volkswagen scandal. Independent tests carried out by the German Car Club proved that under normal driving conditions, diesel vehicles exceeded legal European emission limits for nitrogen oxide by more than 10 times. In 2015, the U.S. Environmental Protection Agency issued a notice of violation to the Volkswagen Group, accusing one of the world's largest automakers of circumventing the EPA's emission test, setting into motion the most expensive emission scandal in history. Some automakers that were involved in the scandal were Volkswagen, Volvo, Renault, Jeep, Hyundai, Fiat, etc. Defeat devices. Defeat devices is a mechanism that causes a vehicle to behave differently during an emission test than on the road. Conceptually, a defeat device has two components. First is the monitor. It determines if observed condition rules out an emission test. And second is modify. It alters vehicle behavior when not under test. Defeat devices rely on any number of external or internal variables to detect that a test is taking place. How it works. The defeat devices assumes that the vehicle is under test unless some internal or external variables allows it to rule out an ongoing test. Then, when the monitor elements signal that the observed variables are not consistent with any known test cycle, the vehicle can switch to an operating regime favored by the manufacturers for real driving rather than the clean regime necessary to pass the emission test. Examples of how the defeat devices were deactivated. General Motors used the fact that air conditioning was turned on in its Cadillac automobiles to rule out a test cycle at the time. Emission testing was done with air conditioning turned off, making the air-fuel mixture richer to address an engine stalling problem. Volkswagen used four deactivating conditions. The first deactivation condition was if the engine has started and a configurable time period has elapsed since the accelerator pedal position first exceeded a configurable threshold. The second deactivation condition was if the engine revolution counter exceeds a configurable threshold. The third deactivation condition was if the acoustic condition is never triggered. The acoustic condition can only be set if coolant temperature, fuel temperature, oil temperature, and atmospheric pressure are within the prescribed limits when the car starts. If any of the four parameters is outside the required range, an ongoing emission test is ruled out and the acoustic condition is never activated. The fourth condition was done by computing a time and distance measurement. The time measurement is computed by measuring the time since the vehicle first exceeded a configurable velocity. The distance measurement is the distance in the current driving cycle. So, the defeat devices in some vehicles use environmental parameters, including time and distance traveled, to detect a standard emission test cycle. If the engine control unit determined that the vehicle was not under test, it would disable certain emission control measures. In some cases, leading the vehicle to emit up to 40 times the allowed nitrogen oxide. Example of acoustic condition activation logic. This is Volkswagen Passat acoustic condition activation logic, dated December 2009. The portion shaded light blue disables the so-called customer-specific acoustic conditions if the distance traveled as a function of time falls outside of all 7 possible test cycle speeds. Consequence. Many automakers were fined. For example, GM was fined 11 million and forced to recall all affected vehicles. Volkswagen was fined 14.7 billion and forced to recall all affected vehicles. Fiat Chrysler was fined nearly 800 million and forced to recall all affected vehicles. Conclusion. As software control becomes a pervasive feature of complex systems, regulators in the automotive domain, as well as many others, will be faced with certifying software systems whose manufacturers have an immense financial incentive to cheat. The United States Environmental Protection Agency has taken numerous enforcement actions against car makers and other companies that have used or installed defeat devices, whether deliberately or through error or negligence. Aftermarket parts or software, such as modified exhaust or chip tuning products and services, are considered defeat devices if they inhibit or bypass a vehicle emission controls. In May 2017, the 28 EU member states agreed to begin negotiations with EU institutions to revise their methods of testing vehicle emissions toward real circumstances, with random testing of vehicles on the road and fines for manufacturers who breach the rules. Thank you.